All right, so let's take a look at 7.2 part 1. All right, so the idea of an inverse function, not just an inverse trig function, but any inverse function, is it's a mirror image of the original. Okay? It's a mirror image when you flip it over the line y equals x. Okay, so that's just a rule for any function. If you want to find its inverse visually, just mirror image it over the line y equals x. All right, now for a function to have an inverse, it has to pass the horizontal line test. Okay, back from Algebra 1, you might remember the vertical line test. Okay, that's a little different. The vertical line test is used to prove if something is a function. Okay, the horizontal line test is used to show that you have an inverse that's a function. Okay, not that the original is a function, but it's inverse. All right, so let's think about sine. Bless you. Okay, so here's our graph of sine. And what the horizontal line test means is if you draw a horizontal line anywhere on that graph, it can only hit it once. Okay. So if you draw horizontal line, it can only hit the graph once. You can put the horizontal line anywhere you want. If I put a horizontal line in that picture, will it hit my graph only once? Yeah, it's going to hit it infinitely many times. Okay? So if I put a horizontal line there, it's hitting it more than once. That means that this function itself does not have an inverse. Okay, the only way it can have an inverse is if we kind of limit how much of the graph we're going to look at. Okay, so what we're going to do is pretend like we have our window, okay, right here on the calculator, and we're just going to look at a certain part. Let's try that part. Oops. Okay, if I look at just this part, and I put a horizontal line in now, would it still hit my graph more than once? Yeah. So that's narrowing it down and just looking at that part. That's not going to work. Okay, but if we slide it a little bit, and we look at something like, well, just about like that, we can make it so that if we draw a horizontal line, it would only hit through once. I'd have to just make it a little smaller. Okay, so that's our solution. When we look at inverse functions, we're going to kind of narrow down what we look at. Okay? So we're going to restrict the domain and pretend like it only exists from negative 90 to positive 90. As long as we do that, we can talk about inverses. If we don't do this, we can't. Okay, so in degrees, negative 90 to 90. And the other problem is if we didn't do that and you pressed inverse sine on your calculator, you would get multiple answers. Okay, what we want is one answer. Okay? The reason you'd get multiple answers is if you think about that horizontal line, you'd get an answer everywhere that horizontal line hits the graph. Okay? The calculator's got to give you one answer. And we're going to agree that the answer for inverse sine is always between negative 90 and 90. Okay, try it. Try inverse sine of 0.6. Okay? That number is between negative 90 and 90. Oh, sorry, inverse sine. Let's try a second. Inverse sine. Okay, 36. Try second inverse sine of 0.89. 0.89. 0.8, that works. Okay, I get an answer between negative 90 and 90. Okay, as long as you pick a number that you can plug into inverse sine, the answer, I guarantee you, will always be between negative 90 and 90. Now, if you pick a number like inverse sine of 5, well, that's a problem. Because how high does the graph of sine go? 1. So if I put a line up at 5, where would it hit it? Never. So if you try to do that, you're going to get an error. Okay? So you've got to pick values between negative 1 and 1 when you do inverse sine. And I guarantee you hit enter, it's always going to be between negative 90 and 90.
What if the lines were like higher? Like could they go higher?
No.
They're always going to be like that?
You always got to pick something between negative 1 and 1. Yeah. When we're plugging into inverse sine. Right, and I'm going to mention that right now. So this is the graph of sine. That is not the graph of the inverse. That's just the original, okay, just the sine wave. We just said it. What's the range on it? How high and low does it go? Okay, so on this one, the range, okay, you've got this in your notes from a couple weeks ago, is negative 1 to 1. And the domain, yeah, let me just put this box back. What are we limiting the domain to? So the height is negative 1 to 1. But what's the left and the right edge of that box? Yeah, we agreed we're going to limit it negative 90 to 90. Remember, these tick marks, they're each 90 degrees. 90, 180, 270, 360. Okay? So our domain here, negative 90 to 90. Okay, that's in the original sine function. Well, what's going to happen in the inverse is that's going to switch. So now instead of the range being negative 1 to 1, in the inverse, the domain is negative 1 to 1. Okay, that's what inverse functions do. They switch the domain and range. Okay, and now before, let's go back up and look at it again. Our domain was negative 90 to 90. What's the domain going to become now?
Negative domain?
Well, the domain is going to turn into the
Range.
range. Okay, they switch places. It's a little confusing to say. But now my range is negative 90 to 90. Okay, or if you're doing it in radians, negative pi over 2 to pi over 2. All right, so if you want to see a picture of what inverse sine looks like. Okay, I'm in degrees, so I have to adjust this a little bit. For my domain, I'll go negative 2 to 2, just so it's not right on the edge of the screen. All right, so let's go negative 2 to 2. And for my range, what did we say, negative 90 to 90? All right, let's just do that. Do negative 90 to 90. And slowly, that's a graph of inverse sine. And that's it. Okay, if you were to zoom out, you're not going to see anything more. That entire section, that is inverse sine, because we're limiting it to what we just said. It's always going to be between negative 1 and 1, left to right, and between negative 90 and positive 90, up and down. Right, so any question on the domain and range of inverse sine? Yeah?
I thought you said that we did the original, later on the inverse, that either the domain or the range switch.
Yep, they do. Okay, so in the original, the range was negative 1 to 1. Now my domain is negative 1 to 1. Okay, it's switched. Yeah? So my range was negative 1 to 1. Now that becomes the domain. Originally, my domain was negative 90 to 90. Now that's going to become the range. So these two things just switch places.
Oh, I wrote it wrong on the top.
Yeah, those in the inverse, they just switch places. Okay, -1 to 1 becomes the domain. -90 to 90 becomes the range. Does that make sense?
Yep.
Okay. Okay, and I'm not going to go through this this picture. Okay, each time how we can limit it. I'm just going to show you for inverse cosine. Okay, so for inverse cosine, your domain is -1 to 1. And your range is 0 to pi or 0 to 180. Right, so if you wanted to see a picture of inverse cosine. Okay, my domain is -2 to 2. And this time I'll set my range. I'm in degrees, so I'm going to go 0 to 180. And that's a graph of inverse cosine. And that's it. If you zoom out, you're not going to see anything more. That's the whole graph right there. Okay. All right, now inverse tangent. Okay, so tangent's a little different than the other graphs. Does anybody remember what tangent had that the other graphs don't? Those lines that things get closer and closer to?
Asymptote?
It had asymptotes. So tangent. In fact, I'll just show you the picture on here. Okay, so tangent had those asymptotes, okay, and it kind of curved like that. Now, in tangent, the asymptotes are vertical. What do you think is going to happen in inverse tangent? They're going to become horizontal. Okay, everything switches places. Okay, and if we look at just this one section, okay, because I want to pass the horizontal line test, so I'm going to ignore every other section. I'm just going to focus on the one in the middle. How high and low does this go? Yeah, the range is -infinity to infinity. -infinity to infinity is going to become my what in the inverse? That's going to become my domain. So in the original, the range goes up and down forever. In the inverse, the domain goes left and right forever. Okay, and vertically, my asymptotes in the original are at -pi/2 and +pi/2. Well, now that's going to be my range. Okay, so originally the domain was -90 to 90. Now the range is -90 to 90. Okay, let's take a look at this one. All right, so my domain goes left and right forever. So, I mean, we could leave it, let's just go -100 to 100, that's fine. And my range, I have to go -90 to 90. Okay, and you notice what kind of happens here is there's asymptotes, horizontal ones, and it gets towards the middle here and it curves up sharply and keeps going. All right, depending on my window, I could change how sharp that curve looks. If I did something like this, it's the same graph, but now the curve looks a little more gradual. But the point is, there's a horizontal asymptote, curves up, and then another horizontal asymptote. Right, and that's your inverse tangent. Hey, any question on the domain and range of any of the inverse trig functions? Okay, if you've got them written down, you don't really have to think through them each time. All right, so these properties we're going to look at, we already kind of looked at them yesterday. What I'm saying here is if you do inverse sine and regular sine, okay, type that in on a calculator, these two things cancel each other out. And the answer that you get is whatever is right there. Okay, we did that a lot yesterday. If we had something like sine of x equals 0.5, right? And you want to get x by itself. Well, you take the inverse sine and inverse sine, and now you've canceled those out, and you have your answer by itself. Okay? So that's the rule we used yesterday. Now, I didn't tell you this yesterday, but this rule only works if your angles are between negative 90 and positive 90, okay? Or negative pi over 2 and pi over 2. How come we didn't need to think about that yesterday? Think about the kinds of angles you deal with in a right triangle.
Right angle.
They're always acute, right? You never have an angle that's not acute. So there would never be a situation where you would have a 190-degree angle in a triangle. Okay? If you did, this rule wouldn't work. Okay? This rule only works from negative 90 to 90. Okay? But yesterday, that's all you had to deal with. Okay? So it always worked. Okay, this rule is similar. We don't use this one as much, but it's when the inverse and the regular trig function are flipped. So what I'm saying here is regular sine and inverse sine cancel each other out. But they only cancel each other out if the number right here is between negative 1 and positive 1. All right, so let's try it. Let's try sine of inverse sine of 0.4. Okay. When I hit enter, those should cancel out, and what should I get? 0.4. And I do, okay, because that's a number between negative 1 and 1. Okay, what if I type in negative 0.6? Is that between negative 1 and 1? Yeah. So that cancels out, and I get the same thing back. Okay, let's try 1.6. Is that between negative 1 and 1? No. So now when I try to do that, it doesn't work. Okay, so my point, this formula only works when x is between negative 1 and 1. Right, and we've got the same idea for cosine. Okay, inverse cosine and regular cosine cancel each other out. As long as your angle is between 0 and pi, or 0 and 180. Again, we used this idea yesterday, but I didn't have to tell you this because you were always dealing with acute angles. You'd never have an angle in a right triangle that's not between 0 and 180. And then formula 2b. Okay, for this one, you could think again, if you drew cosine, what's the highest and lowest that the cosine function goes? Negative 1 to 1. And that's where that restriction comes from again. If you try to go above negative 1 or below negative 1, you're basically, think of drawing a graph like this and asking where that line crosses it. You're going to get an error. Okay, you've got to stick between negative 1 and 1. And if you want to try it on your calculator, you can just plug in some numbers and try them. All right, and the last formula, okay, inverse tangent will cancel out regular tangent. And the answer will be whatever is right there, as long as your angle is between negative 90 and 90.
We'll cross out again the tangent.
Yep, these two things would cancel each other out. And the answer that you're going to get is whatever is right there, as long as your angle is between negative 90 and 90. Right, so you could try it on your calculator. Try typing in inverse tangent of 10 degrees. When you hit enter, the answer that you're going to get is 10 degrees.
So it can't include 90?
Yeah, that's an important point this time. You can't include 90. Because remember what happens if you try to take the tangent of 90? There's a vertical asymptote there. It's undefined. Okay, so yeah, that's actually a very important point. The other ones had equal to's. This one does not. So you can go up to like 89.9 repeating. Okay. And then formula 3b, that one works all the time. Okay, and it works all the time because if you think of tangent, the original goes up and down forever. Okay, has this shape to it. That's kind of where the negative infinity and infinity come from. Okay, from that shape. All right, so these are formulas. I would put them on your reference sheet. Okay, I wouldn't try to memorize them because it's a lot. It's a lot of numbers. It's not hard, but it's a lot of things to keep straight. So it's handy to know when these formulas work and when they don't. Okay, so a sample question you might see on the test. I might say true or false. The sine of the, bless you, inverse sine of 1.2 equals 1.2. Okay, so go back up, find the formula where sine is on the outside, inverse is on the inside. Look at what it has to be between.
So that's between -1 and 1.
Is that between -1 and 1?
No.
No, this is false.
Is that the basic question what's going to be like? Just have
Yeah, it would be something like that. Okay. Or I could say simplify. Just going to keep it simple. The sine of the inverse sine of 0.3. What would that equal? 0.3. On a simplify problem, don't write true. Okay? True doesn't tell me anything. If it's simplify, you need to write a number. Okay? So that's the kind of questions you would see for that.
So we're just taking that x that's inside.
Yeah, you
Does
just
it cancel out?
yeah, you're just looking at that inverse sine is on the inside. And all right, he said those cancel out as long as I'm between -1 and 1. Yeah, 0.3 is between -1 and 1, so I'm good. I wouldn't give you one that's undefined to simplify. Okay, if I ask you to simplify, it's going to have an answer.
What if the inverse of sine is on the outside and the sine is on the inside? Do they still cancel out?
If the inverse is on the outside, then you got to check for a number between -90 and 90.
They don't cancel out.
Yep, they cancel out as long as you're between -90 and 90.
Oh.
Okay? Or negative pi over 2 radians and positive pi over 2 radians. I like working in degrees better, so if they give me a problem in radians, I usually change to degrees. It's just easier for me to remember -90 to 90. All right, transformations on these functions work exactly the same way they always have. Okay, so I'm not going to go through everything because you guys have this in your notes from 10 times we've done it. But A is your shift left and right. B is your stretch left and right. C is your stretch up and down. D is your shift up and down. Remember, A and B do the opposite of what you would expect. So if you see a plus on A, plus A is going to shift left. Minus A is going to shift right. Okay, so these two do the opposite. We've mentioned that for every function so far. All right, so if we transform a trig function, we're changing the domain and range. Okay? As long as you know all the original domain and ranges, it's very easy to find the new domain and range. Okay, so I would make sure on your reference sheet, put the domain and range of the original trig functions.
So what you gave us earlier?
Yep. I gave you the domain and range for inverse tangent, inverse cosine, and inverse sine. So I gave you all 6. Okay, so now to find the new domain, okay, what we're going to do is create a compound inequality, okay, with the argument, that's the argument right there. Put the argument in the middle. And we're going to put the original domain on the left and on the right. Okay, I'll show you an example. Okay, the only reason we're dealing with the argument here is because domain is your x, that's your horizontal. What I just circled right there is your horizontal. If I shift something up and down, that doesn't affect the domain. That affects something else. What if you shift up or down, what would that affect?
Range.
That's the range. If you stretch up and down, what would that affect? That's the range. Okay, so I don't care about C and D when I'm just trying to find domain. Okay, I care about C and D when I'm finding the range. Okay, so to find the range, all we have to do is take into account, did we do any stretching? And did we do any shifting? Okay, and I'll go through some examples of each, and these are actually pretty easy. They're not that hard. And you don't have to graph anything. You just do it all on paper. All right. So the first one says inverse sine 2x. First of all, I'm only doing one thing here. Okay. I put a number in the spot where I had b up above. So one of these is going to stay exactly the same. Which one is not going to change here? The range. I'm not stretching it up and down. I'm not shifting it up and down. So whatever the range is for the original inverse sine, let's just copy that down.
So it's like negative pi over 2 to
Negative pi over 2 to pi over 2. That stays the same. Okay, and the domain, okay, what does it say to do? Create a compound inequality with the argument in the middle. There's your argument right there. Put the argument in the middle. Put the original domain on the left and the right. The original domain was negative 1 to 1. All right, so I put negative 1 to 1. Always have your inequalities pointing towards the smaller number. And now just solve for x. Okay, so how would we get x by itself here?
times
Divide by 2. So divide by 2, divide by 2, divide by 2. So now x is not between negative 1 and 1. What's x between now? Negative a half and a half. Yep. And that's it. That's my new domain. Okay, negative a half to a half. All right, let's try this one. Inverse sine of 1/3 x. What's not going to change here?
Range.
The range. Okay, if you put a number in front of x, we're doing something to the domain. So the range is exactly the same as what it was originally. We just copied that down from the last problem.
So one.
Okay, define my new domain. Take my argument, put it in the middle. Take my original domain and put it on the left and on the right. Right, so now what would I do to get rid of this 1/3?
Times by 3.
Times by 3, times by 3, times by 3. So what's my domain now?
Negative 3 to 3.
Negative 3 to 3. That's it. If you really want to graph this, you could double check, but there's no need to. Okay, I've been doing a lot with inverse sine, but you could use any of them. Okay, just go back and look up what you need. Okay, what's going to stay the same here?
Y or range. Domain x.
Yeah, the domain's going to stay the same.
Yeah.
what this plus 2 is going to shift everything up 2. So originally my domain is negative 1 to 1. That's not changing. And my original range was negative pi over 2 to pi over 2. And what's that plus 2 going to do to it? Shift it up 2. So very simply, all I'm going to do is say shift that up 2 and shift that up 2. I don't know what the decimal is. That's not important. Okay, the range just bumps everything up 2. That's it. All right. Inverse cosine, so be careful on this one. You might have to go back and look something up. What's staying the same this time? What's this 5 going to do?
That's going to change the range.
It's going to change the range. That's a vertical stretch.
So that's
Yep, so the x's stay the same. So if you don't remember what the domain is for inverse cosine, go back and look it up. Inverse cosine, domain, negative 1 to 1. We're not changing it. And now this 5 is going to stretch everything by a factor of 5. Okay, so let's go look at our range for inverse cosine. It's 0 to pi, and we're going to stretch everything by 5.
so 0. So
Done by
it'd be
five.
5 to pi plus 5.
So stretch means you multiply everything by 5.
So 5 is 5 pi.
No, 0 times 5 is not 5.
I mean 0 and 5.
0 to 5 pi. Yep. Okay, so now that's 0 to 5 pi. Okay. If you ever had to do, like, let's say you have this, you always do follow PEMDAS. You always do multiplication before addition and subtraction. Okay, so now I would multiply by 5, and then I would just do plus 1 on the end. Okay, I'm not gonna do one like that though. Okay. Let's start with the number that's affecting the domain. Okay, which number affects the domain there? The 3 or the 2?
2.
The 2. So we put the domain in the middle, and we put the original domain on the left and on the right. All right, so we got negative infinity to infinity.
Divide by 2.
You divide by 2,
Would it still be an infinity though?
it's still negative infinity to infinity. You can never change the domain of inverse tangent. No matter what you do, it always stays the same. And now the range. Okay, the range was negative pi over 2 to pi over 2.
Times.
And now we're going to triple it. So instead of negative pi over 2, triple it. Okay? And instead of pi over 2, triple it. Okay, any questions on that? All right. This one, we've done this kind of problem before, list all the transformations. I'm just going to give you a hint. If they have this number in front, that's not normally how we write it. I would write it like this. Okay, so who can tell me real quick, what's the plus 2? Shift, yep, left 2. So you know what, I'm just going to write it real quick. Left 2. What about this 1/4? Be careful. That's a horizontal stretch by how much? By 4. Remember, this does the opposite of what you would think. Small numbers stretching. So horizontal stretch by factor of 4. What about the 3? That's a vertical stretch by a factor of 3. And what about the minus 5? Down 5.
So if it's like a fraction, we do the opposite of what a fraction is.
Yeah, if it's inside the parentheses, it's always the opposite. Yep. And the last part, I don't think we need to do. You guys did a lot of this in the homework. Does anybody have a question how you type an inverse trig function in on the calculator?
No, it's
Like this one would be undefined. Remember, you can't go above 1. Right? These other ones would be fine. All right, so our last homework assignment for this week, for quite a while, okay, is 1 to 9. Okay, just the odds. 13 to 20, 22 to 24, and 27 to 32. Okay.
everything off. Or like,
1 to 9 is all odds, yeah. Everything else is just normal. We'll go over that tomorrow, and tomorrow we're just going to do a review in class of what's on the test.